Okay, so good afternoon to one and all present here. I hope it is the audio is clear and the slides are visible to you all. So I will not take too much of time to discuss about all these things. After that I will be switching to the next part. So I will be taking 10 to 15 minutes to complete this part. After that I will be starting with the OSI model and then data and signal. So wait for 1 minute. Okay, so it's already 1:10. So a very good afternoon to all. So in the last class we discussed about the syllabus, and in between that in the last week I was not there, so I have not detailed what are the things. So category wise what we discussed were the point and multi-point we discussed in the last class, and SND sir also have discussed with you what is point and multi-point. So it is a point to point connection, that is from one node to only one node it is connected, and when it is point to multi-point then definitely from one node multiple connections exist. Okay, that is the simplest thing that you can remember. So definitions are there. So if it in the case of point to point connection, dedicated link will be there between two devices, right? And in case of multi-point you have it is multiple devices are connected using the multiple number of connections, and in between to any two devices you will be having only a single connection. So that is in case of multi-point. Next, when we categorize the network into three things, basically the LAN, WAN and MAN, and all the things you know very well, I don't want to repeat the same thing. That is LAN connection in a single building, you know, so the periphery is limited in case of LAN. When the periphery is within the city itself, it is the metropolitan area network, that is MAN, and when it is the world wide web, so it is the wide area network, that is WAN. Okay. So if you think that distance wise this LAN, WAN and MAN, these three things differs each other. Topology wise, because I think SND sir and SKG sir has told you, but in the physical layer these things are there, that's why I am repeating this one, but I will not take too much of your time. So what do we mean by topology? Topology means basically it is there are two types, either is a physical or logical. Two types of topologies are there, but here we are dealing with the physical topology. That is how physically the nodes means your computers or laptops or mobiles, whatever who is capable of transferring the data, that is known as node. So how the nodes are connected physically, that is given by different physical topologies. Okay, what can be the four basic fundamental topologies? Either mesh or star or bus or ring. Nowadays if you think of a total network in any of the metros, like in Kolkata or Chennai or whatever is the location, so it is not a single topology. Suppose all the servers are connected via suppose some ring network, that is also done through the optical fiber, right? So if it is a ring, all the servers and all the main ISPs are connected through a main fiber backbone, that is not using star or something like that mesh, that is using only a ring topology. Now there are different types of ring topology that exist. So when it is a normal metropolitan area network, it is not a single topology, it is a collection of topology that also exists, that is known as the hybrid topology. So what do we mean by hybrid topology? Hybrid topology is a type of topology where it is consisting of not only mesh or star or bus, it is a mixture of different topologies. Okay. So, the question I am just telling you, in case of the numerical questions that you have, so if I tell you that you draw a network that consists of star, ring and mesh, can you draw this? You need to draw, you can write down the question, design a network consisting of star, ring and suppose bus topology. Can you design a network? This type of logical question that we can just give you in the exam, or how many links will be there, how many links will be there if there are n number of nodes. Okay, so you need to write one comparison between what are the topologies present. Suppose you are using mesh, what is the number of links required if the number of node is n. Okay, so in that case this is the number of links that you will be requiring. So what happens in mesh, each and every points that are connected, okay, that is this two, that is if you think this is a computer that is connected with this, this and this, that is each of the node is connected with other nodes, each of the node is connected with other nodes. Okay, it is written clearly here, directly to every other device with cable. Every other means it's like a mesh type of network. Now when we talk about the drawbacks of this type of topology, you can find out that the number of links or the number of wire is huge. Okay, it's a mesh of wires that you are using, that is not required at all. Okay, so the main problem is a huge amount of wires are required, that's why the cost is very high. So if the cost is very high, the installation part is also very difficult, because you have to handle too many number of wires. Now if you are using some Cat5 or Cat6 cable, there is no problem, but if you are using some optical fiber link itself, so optical fiber is very costly, and along with that the installation cost is also there, because the splicing machine that is using, that they use, that is splicing machine means they need to join the two fibers, right? So until and unless you are joining the two fibers in between, how will you create one big network? It's not a single fiber cannot support 50 miles, so in between you have to join the fiber. So all these things are there. So if it is a normal network, fine, the cost is high. If it's a fiber optic network, mesh network, that cost is too high. So we do not prefer such network at all. Okay, so in certain scenario we will be considering, but not for all scenarios we will be considering. Now for sake of understanding, I have drawn one mesh topology using a packet tracer, because packet tracer is another software that you will be using in the lab also, and how you are designing different topologies using packet tracer, we can discuss about that. So this is actually the forefront of the software, and these are different devices, like these are it can be switch, hub or servers are there, and there are different end devices. End devices means you might have some PC or laptop or desktop. So suppose these are basically 4 computers I have connected with 4 suppose switches. The switch specification is 2940 is the switch specification we have used, and we have done some simple mesh network. And how the packets are moving, that the trace is you can get the trace here. Okay, this is a simple snapshot I thought of sharing with you, how you can manage this mesh topology, and you can practically do this. Okay. Now in case of bus topology, you know that it's a linear bus structure, because a single backbone is there. This is a single backbone through which different computers are connected. So this is a single bus topology, and linear bus topology is used. So you know that what is the drawback of this. So if some problem arises in this main backbone network, so all the computers will be disconnected. So if some breakage, suppose some fiber optic breakage is there, so the breakdown will occur, and finally the connection will be distorted, that is you cannot send the packets, right? So you can think of the problem of this, if the cable failure happens, then you will be totally isolated, you will become totally isolated with the rest part. Yes, Aryan, in mesh too many multiple links are there, that is correct. Yes, mesh is good for, I told you this depends on the scenario when we will be using this. It's not at all that we will be always, but certain scenarios it is definitely advantageous, that is, there is no doubt about that. Okay. So, bus is cost effective, as you can see that the number of var is somehow reduced from the mesh, because in the mesh you have too many number of vars, but in bus the number of var is all the nodes are connected to the single backbone that is there, and so the cost is less because the number of var is getting reduced and associated things are there. You can read out the slide and you can easily understand, it is self explanatory, and you have already SKG sir has told about this. Okay. Now ring topology is very important, because practically in many scenarios we use the ring topology, and its scenario in two cases it can be unidirectional or bidirectional. That is, if it is bidirectional, that type of ring topology is known as the dual ring topology. Okay. So in this way, if you can think of, like, if I put a ring like this, so if the nodes are like this, okay, so this is a single direction, unidirection. Single direction is known as the unidirection, but if both the ways the reverse direction is also feasible, then it is known as the bidirectional. Okay. So the ring topology can have two types, either it is dual ring or single. So dual is much more preferred, because if one link is going to fail, then the second link is going to support the system. That's why dual ring is much more advantageous than the single one. As I told you, if suppose one of the link fails, the another link is going to have the support with that. So this is the typical stations. Stations means, you know, that these are basically the nodes. Every time I tell this word nodes, because when you are using some in research papers, you will be using like ad hoc networks and all these things. Though computer, it can be node, can be any of the thing, like it can be some PC or the laptop or your mobile gadgets, whatever may be the thing, so which is capable of transmitting the data. Now repeaters are, what is repeater? Repeater is basically when you are sending some signal, after, suppose you are sending some signal, right? So after traversing certain distance, you will find that it is getting attenuated. What you will get? So when the signal is sent after certain distance d, it will get attenuated. So to reboost the signal, I am telling, to reboost the signal, actually repeaters are used. To reboost the signals, repeaters are used. Okay. So there are typical repeater, it's not amplifier. In digital world we talk about repeaters. In analog, when it was the full analog domain, we used amplifiers. In case of amplifier, the amplified signal as well as noise, both are amplified. So in case of repeater, only the signal part will be amplified. So modern communication is optical fiber channels, because I told you the optical fiber links are there, okay, that is creating the ring, and they are using the repeater or booster stations. These are also called the booster stations. Okay. So this is somehow the I tried to tell you, and definitely there are some advantage, and yes, many of you have told that you have heard of the term. Okay. So certain advantages and disadvantages are there, but the disadvantage we should point out, that is, it is the troubleshooting is very difficult, you know, because because you can see here the stations are connected in both the ways. Okay, so this is, if you think of this station, it is connected to this link and this link. So if some error is happening, it is difficult to find out in which path it is creating the error. That is, fault detection in the path is very difficult. Okay, that is known as the troubleshooting we are talking about, as well as adding and deleting the nodes. When you want to add something here, suppose you want to add one new station here, so you need to add the repeater and all these things, you have to reconnect with this, so reconfiguration, all these things are there. So it is very cumbersome in case of ring. Previously it was not that in case of normal mesh or the bus, linear bus that you have think of. Okay. Now if you think the new another type of star topology, that is very renowned topology. Star topology, we use the concept one central hub or switch will be there, and through which the data is going to be connected with all. Okay, so if it is there, so there will be multiple number of so this is the central hub through which the things will be connected. Okay, right. So this is the thing, and we know that the star takes more cable than a bus, that is true, but the benefit is that if a cable fails, that was the problem of normal bus topology, only one node will be brought down. Okay, that is the problem that can be taken care of by the problem of linear bus can be taken care of by the star topology. So there is the star topology, and all the topologies you can create in the packet tracer. Okay, that is the assignment we can give you, that you all of you can do when you will be learning the packet tracer. The topologies you can implement by yourself. Okay. So this is the thing, star topology is there. I am not discussing too much. This is a switch and all these things are connected. So if you divide the type of topology in two category, mesh, star and ring belong to point, and bus, because in bus connection you have seen all the nodes are connected through a single bus. There is no concept of point to point. So in that case you can think of that bus topology is a kind of multi-point configuration. Now this is the question or the assignment. Can you just take 1 minute of time and do it? The question is that you assume 6 devices that are arranged in a mesh topology. How many cables that are required, and how many ports that are required for each device. And second question is that if n devices are there, you have to write one comparison for all the 3 cases, means how many links will be required for all the cases that you have seen, that mesh, ring, bus and star. These are the 2 assignment. You can note it down, later also you can do it. Take 2 minutes of time and try to solve this. Okay, so this is the part. I will not waste my time. So the second thing is that I will be discussing with the TCP/IP. That is the question or the assignment. You do it, you can solve it, and later also you can send it to me. Now, so that is the pending part actually. So this is the week 2, that is the scheduled part. So in the first module you have seen that many things are there. In the first module itself, the different types of topologies are also there. Okay. Now here we can find that the concept of OSI model and both the TCP/IP model, and why we are coming to the different models, what is the reason behind it, and what are the functionalities of each of the layers, and what are the different protocols that will be there. Okay, I will be observing all the answers. Take your time and try to solve it, but not now. Okay, let me finish it first, then. So when we are discussing about this, we will be talking about OSI model, and I I'm telling you just like a simple example that OSI model describes 7 layers. Okay, that layers are the computer system, how the computer system is going to communicate over a network. Okay, and it was first a standard model for the network communication, and majority of us adopted this one. But nowadays we do not use the OSI model, we use the TCP/IP model. Okay, but we have to learn the OSI model for sake of the exam, or what can you say. So if I talk about OSI model, actually OSI model was introduced in 1983. Okay, but later it was adopted by ISO. Okay, that is a standard, international standard, in 1984. Okay, ISO actually accepted it in 1984. From that time itself we are using this. So there are 7 layers which is known to you. Now what are the layers that are there and what the functionalities of that, we will come one by one. Now in this regard, one important thing is that the 7 layer, each of the layer is following some protocol. Protocol means what? Protocol is the rule. Okay, rule means how the layer is going to work, that is the rule that is defined for each layer. Now in case of protocol, you can see it is a set of rule that is used for the communication, and that is separate for separate layers. Okay. Now when we are talking about 7 layers of OSI, the first layer is basically the physical layer, that is you know. So if we start with the 7th layer of OSI, this is application, and basically you can see that human computer interaction layer. How you can see this? This is a human computer interaction layer, means where the applications can access the network services, that we can think of. Okay. The applications, what can be the applications? Let's suppose you are opening some browser in Firefox or Chrome, those are the applications, or you are within that you are using different process. In one tab you have opened the Facebook, in another tab you have opened the any banking transaction, in another tab you have used some normal online game or online compiler, you are writing some code. So within the same process, within the same process you are using, within the same application you are using multiple processes, because within the same browser you can open multiple things. So all these are individual processes that are getting executed, right. This is the first part. Now second part is that the presentation layer. Presentation layer means we need to convert the data. So whatever, suppose you are writing some mail to your boss or your subordinate, so it is in the Gmail, so you open the tab, okay, and you have opened the Gmail and you are writing the letter in English, but the computer will not able to understand in which language you are writing. So when you are ultimately in the physical layer, I am just writing, try to understand the concept. So in this layer it is only the, just one second. So there are, suppose like Chrome is there, okay, different applications are there and different process. Suppose you are writing some through some Gmail, so you are writing some letters, okay. So when you are writing some letter, it is in the alphabet English. So what, all these things should be converted into ASCII, right. So it is the ASCII conversion, that is, so formatting, data formatting is important, that is one part of the job, okay. Second part of the job is, it is data encryption and decryption. For security purpose we do the data encryption. Data encryption, many of you are doing the project, so you have seen that RSA algorithm or different algorithm or different hash function you have used for data security purpose. So you have used the private key and public key for data encryption. So data encryption is another work I am using the tab of this room, so it's not working properly. Anyways, data encryption is another part of the just. So ASCII means English letter to ASCII code, and then you encrypt the data. There are different algorithm, whatever the data it is coming, you need to encrypt, and you can change the format if you want. Okay, all these things. And data translation is also there. Now what is the session layer? Session means suppose you are making some banking transaction. So what you have done, or you are observing your mark sheet from IMCRP. So you are logging in the IMCRP portal, then you are just using your what can I say, your username and password, you are creating the session. Okay, then after logging in, so from login to then first is login, you do the login part. Okay, then you access the data, and then you do the logout part. Okay, so you are creating a session in case of, not only in case of IMCRP, when in case of suppose the banking transaction. Okay, you will create what? So SBI portal or Axis portal, you are just logging in, you are accessing the data, and then you are logging out. So what you are doing basically, you can note it down. So this session layer creates the communication channel or sessions between the devices, like your end device and the server, and it is capable of, what can I say, it is opening the new session. So the session will not end, right? The session will not end until and unless, maybe due to some internet issues it may end, but until and unless the data is getting transferred, the session is not supposed to be ended. Okay. Next you have the transport layer. In the transport layer takes the data from the upper layer, that is this from the session layer. So it is basically the top down approach. So when you are sending something, it will be the top down approach in case of transmitter node. So in case of, this is the node basically, that computer, and so all the things are there, right? All the things are happening one by one, and you are sending something here, means all the modules are coming top down, then passing through the physical layer, and then it is bottom up. This is the way the things are happening. Okay. Now in case of transport layer, what will you get? Okay. So you will be getting the data, whatever you are getting from this session layer, you will break into segments. Okay. So PDU is a concept, that is a PDU means for each layer a packet data unit will be there. Like for this it is bit, for this it is suppose frame, for this it is packet, for this it is segment. These are the PDU names. I am writing it here. Data, this you can say here. Like a bit or baud rate, baud or bit, whatever you like. It's not working. So these are the names. These are the names of the PDU. Here it is suppose the data. The name is data, then segment, then packet, then the same data, the nomenclature is getting changed. Okay. And here bits means in terms of raw 10111, so raw data bit that you are getting. So some header is going to be added, okay, like your source address, destination address, all the headers, some other error correction codes, all the headers. When you are passing from one layer to another layer, all the headers will be added with one another, and you will be getting a big frame, like big stream of bits at the last then the bit stream is going to be transmitted via some copper cable or optical fiber link or radio or microwave link. So, the process will be top down from writing one thing Gmail to all the processes. Ultimately in the physical layer, ultimately it is getting converted into bits, and finally you are sending through some, it's very difficult to write here, I do not know why, some pop-up will come up, and like it can be some coaxial cable or it can be some microwave or it can be optical fiber cable or whatever is a Cat5, Cat6 coaxial cable, whatever is the thing. So, through which ultimately the stream of data will be passed. Okay, this is the thing. Now, this is the interfaces between the layers. So, in between two layers there exist some interfaces, like suppose 6 and 7, 5th and 6th, 4th and 5th. So, in between each layer the interfaces exist. Okay, and suppose you are communicating with the 7 to 7, this is known as the peer to peer protocol, that is happening between 7th layers or 6th or 5th or 4th, like that way. Okay. Now, this is already I have told you these points, but still you can find it out that the top down approach I have already told you, right? The top down approach is already told you. So, when the message is passed from top to bottom, okay, like from application to normal physical layer, the motion will be from top down approach. Okay. So, the message descends, okay, and each successive OSI layer adds a header. I have already told you. So, when you are passing from one layer to another layer, some data will be added or some header will be added. So, it is a reverse one. At the receiver the reverse thing will happen, right. So, when some data is coming already through some coaxial cable, or so data to ultimately you will be getting the Gmail or reply. Okay. So, you will be getting data, then some headers will be added like MAC, LLC. MAC is media access control, LLC is a logical link control, IP you know, internet protocol, and TCP you know that. So, all the headers will be added one after another, and ultimately you will be getting the final data here. It will be better shown in this picture. So, headers for each layer header is connected. For suppose data 7, some header will be connected and this data is passed from application to next is presentation, then some here some header will be added and then sent to session. This way the whole thing will be passed through physical layer, and physical layer you can think of it is basically the stream of ones and zeros, and ultimately it is passing through the transmission media. What can be the transmission media? It can be some like simply I told you twisted pair cable or coaxial cable like Cat5, Cat6 cable, or RF, that is RF microwave link, or any optical fiber cable. These are the examples of transmission lines or transmission mediums. So, when the reverse thing is happening, that is ultimately you are communicating this way via this way. This is your process or aim, right. So, you have done, you have converted the letter into this stream of bits. This has been passed through the medium, any of the medium, and then from bits back to the letter. That is your objective. So, this is the way. The header encapsulation is important. What I wanted to tell you, each layer is going to add some header, and ultimately you will be getting the final data in the physical layer here in form of bits that is going to be transmitted, and at the receiver from bits back to the letter. So, the reverse thing will happen, whatever the thing that has been done from this to this, the reverse thing will happen, and ultimately you want that letter. So, ultimately somebody X is sending some letter to Y. So, all the processes are happening in between, that we are not actually what can I say, that we do not know what is happening. So, this is in a nutshell I am telling, these are the processes that are happening in between. So from this slide onwards, basically I told you that there is certain a bit detail in discussion. Already I have told you, but in slide I need to keep all these things. Like you can see here, I have written that in the OSI model it is the closest to the user. So I told you is a human and computer interface, you can see in human computer interaction layer I told you. So closest to the user, UI, XYZ, any of the person that is closest to the application layer. So multiple processes can run, like I told you, like you are opening one tab for the like banking transaction, or you are simultaneously you want to download the grade card from IMCRP, another one you want to do some Facebook or Twitter or whatever you like. So all the things are you are doing. So ultimately what is the interface medium is the web browser. There are different browsers that exist here in Windows and Linux, whatever platform you use. So depending on that, these are the basically the interfaces. Okay. Now what are the protocols that are mainly used in this layer that are very important, and in the application layer the detailing of all the protocols you need to study. Like in the mainly we are all of us are using the HTTP, like it is written already, hypertext transfer protocol or simple mail transfer protocol or file transfer protocol. Lots of other protocols are there, like POP is post office protocol, okay, or DNS is domain names system. These all these protocols are there. You just mention another two protocols. POP is basically I am writing here. You add this two also. Huh? And another vital point I missed is DNS. Domain name system. So in the application layer, detailing of this thing you have to study. Okay. Now presentation layer, I also told you that these are the things. Data conversion means you convert the normal English to ASCII, okay, and data encryption you know, and for data encryption different types of protocols they are using, like SSL, secure socket layer is very famous protocol that we use, okay. SSL is very renowned, many of you know this one, and PGP is also known. And next is the data compression, because when you are sending suppose some GB of data, you need to compress it, compression means already we use that one, like when you are using the zip file format, like when you want to send this some attachment through Gmail or something like that, there is certain limitation how much data maximum you can send. So data conversion consists of the first one is the ASCII, I told you. Just one second. ASCII is the thing. The second one is the JPEG, because for the image part we use the JPEG or PNG, whatever is the format, and for data this is for image, and for video we convert this the MPEG. So whatever the extensions we are using, that are also actually they have used the compression algorithm. After that they have the file has been in this form of JPEG or something. Even if you want to compress more, there is other methods like WinZip or whatever is that, WinRAR is there, you can zip it, okay. So this is the three things I told you, the presentation layer, that is the responsibility of the presentation layer. So session layer, two protocols that are basically important. You will be learning all these things in detail, but at least you should listen the name of the what are the protocol that is important. So this point to point protocol, PPP it's known, or PPTP also it is known, and that is session announcement. These two are very important as far as the examination is concerned. Okay. So what is the main role of the session layer? It will establish one session, like you are logging in through some portal, then you are doing some transaction, that is data, you are giving some data and you are just browsing something within that, and then you are terminating the session, means by using the logout. Okay. So it is a full process, okay, that is basically governed by the session layer. Transport layer, this is also very important. TCP and UDP, these two protocols are very important, and question in whether it is some what can I say, some placement related, if you give this computer networks as one of the paper in your CV for placement, this is the, they will ask you what do you mean by the differences between this TCP UDP. So what do you mean by connection oriented and connectionless protocol? Okay, and which is better, TCP is better or UDP is better? So there are certain things and there are certain areas where we can use this or we can segregate this one. So the few points that I like to mention here, that TCP and UDP, if you think of that, connection oriented is TCP whereas the connectionless is UDP, and certain things that TCP provide but UDP doesn't provide. What are the certain things? Like error control and flow control, that is we will be learning in the data link layer also. So these two are basically provided by the TCP protocol, whereas in case of UDP these two things are does not provide. Okay. Retransmission concept is not here, because if some error is there and you want to retransmit the data packet, in case of UDP it is not possible, whereas in case of TCP it is possible. So TCP is basically better compared to UDP. Okay. Now in the network layer you will be having two protocols, one is the IP version 4 and version 6. What is the format of IP version 4 and version 6? That is a famous question that we give in the normal semester exam. You will see that what is the format of version 4 and version 6. And what are the other protocol, that is ICMP is also another renowned protocol, that is the Internet Control Message Protocol. Okay. This is important, and these are many things are there. It is very difficult to tell in one slide because it will be one chapter itself. Network layer, all the layers are basically containing, because this chapter is very important. This data link, this is very important for GATE. Okay. For GATE exam this is very important. The routing algorithm, all these things are what is the shortest path algorithm, different problems will be coming from this section. Okay. Now this is the thing, and which device we use here in this layer, mainly routers we use. So you need to know, shall we use the normal hub in the network layer? No, we use routers in the network layer. We use the switches or something, intelligent switches in the data link layer, or hub we also data link layer. Okay, anyway, so IP, concept of IP, you know, the different classes it is known to you majorly. There are basically we will be using, so when we will be using the packet tracer, so when we will be providing some IP to the host, right? So the host IP we prefer in class C or class A, class B, so it depends. Okay, suppose there is certain, I am not going to tell about IP and all, but suppose when you are using, suppose 10.0.1.2.3. So which class is this? So 10, if this is basically the host 1 to 127, if it is, so you can think of this is the class A. Okay. So we can categorize. So class A will be like that, 1 byte, you know, 8 bit, and 8 bit maximum 127 will be there, and remaining 24. Okay. So this is 32, 8 into 4, 30, the total will be 32, and you can think of, So 1 byte, 2 byte, 3 byte and 4 byte, 8 bit each. So it will be, the length will be 32 bits. Okay, and each of the byte, if it is class A, the first octet is going to give you the network ID and the rest 3 octet will give you the host ID. In case of class B, the first 2 octet is going to give you the network ID and the rest 2 octet is going to give you the host ID. In case of class C, the first 3 octet, like when you are having suppose one, you can think of the IPs we use 192.168.10.2. This is the another IP, okay, we are using. But so this is a, from here itself we can find this a class C type of IP. Multi-class and reserved class is also there, but mainly we will be using class A, class B, class C, these 3 IP for our packet tracer experiment. Okay. Anyways, so in case of data link layer, I told you what are the devices that you can use in case of data link layer. These are basically the devices, like you can use the intelligent switch or bridge or NIC, that is a network interface card. What is the role of the data link layer? It establishes and terminates a connection when 2 physically connected nodes are there in a network. Okay. So what is the main role? The upper layer is the network and the bottom layer is the physical. It is sandwiched in between these two. So it is getting packets from the network layer. So it converts the packets into frame. Okay. So framing is main job. What can I say? The flow control, error control, framing, these are the main jobs of the data link layer. Okay. And the layer also composed of 2 parts. One is the LLC, another is the MAC. Okay, this is known to you. I will be writing here. This is basically, in short, we will be writing here as MAC. So what is the role of this logical link control? Actually, it identifies the network protocol and performs the error checking, or you can say the synchronizing of the frame. All these things are basically done by the LLC, that is the logical link control. Whereas in case of media access control, it addresses you know what is MAC address? MAC address is a physical address. Okay, IP address is a logical address and MAC address is a physical address. And you know here I want to tell you one thing. The framing, flow control, error control, all those things, physical addressing is the MAC address. I want to tell one thing. This slide I wanted to focus that if you in the command prompt of your computer, you can just type this one and you can check what is the MAC address of your computer. Okay, you can check it and you can see here ipconfig/all you can use and you can find it what is the physical address or MAC address of your computer. This is anyways, this is not relevant, but still. So this is the thing I told you. MAC address is a media access control, and this layer uses MAC address to connect devices and define the permission to transmit and receive the data. Okay, this is the objective of this part. So these are the certain responsibilities that the data link layer is having. Like I told you, flow control, error control. Within the error control, you have the different types of error control mechanism. You will be having the parity part. Okay, parity. You can write it down, parity, CRC, checksum, all these things. Along with that, the different types of coding like block coding, Hamming coding, all these codings are also done in this error control. Okay, in the flow control, you will be having like different types of CDMA or CD, that is a normal thing is CSMA CD or CSMA, that is a carrier sense multiple access. Okay, collision detection or collision avoidance. I cannot write it here, the writing is becoming too problematic here. Something will come. Why it is coming, I do not know. So error control I told you, like the parity will be there, or CRC or checksum, or you have the different types of coding scheme like block code, okay, all this Hamming code. If you see the book of Farhausen, all the things are there. Okay, flow control, you can have this one, the CSMA, the carrier sense multiple access, collision detection, and CSMA, collision carrier sense multiple access, collision avoidance. Okay, and you will be learning other things like there are different other parts are ARQ, and different ARQs are there, 3 ARQs are there, all things you will be studying there. Access control is another part. So framing, there are two types of framing that SND sir will be telling you. Okay, character oriented and bit oriented framing. You have to tell what is the difference between the character oriented and bit oriented framing. Framing, the concept is that whatever the bits you are getting from the physical layer, you are combining some bits into a frame. Like if you have a list of, suppose if it is from physical layer to data link layer, suppose if it is happening the reverse thing is, so it is in the form of 1011 like that. So from this you will be just you are creating some, you are collecting some data and you are creating certain frames. So this is suppose frame 1, frame 2 like that. This is the way the frames are getting created from the raw data. Okay, and this is not a simple thing, I cannot tell you in 1 second or something like that. So MAC address, I told you, MAC address addressing is another part of the data link layer, and it is of 6 byte, and you can think that how we have done this is the ipconfig/all we can use, and you can think of 54-E-7E E477A1, this is the value that is having. So it is each is having the 6 byte, so 1 2 3 4 5 6 bytes. So PPT I will be sharing, you can see there how many bytes are there, 6 bytes are there. Okay, so I have already told you what are the flow control and error control. Okay, these are written here. Okay, one mistake I have done here. So actually these are basically the access methodologies. Okay, and ARQ, I missed this point, I have not, all these are the flow control mechanisms. Okay, I have not noticed that part properly. Multiple access, in between that you have the collision detection and collision avoidance part, and physical layer you have this all these things. So mainly we will be learning the line coding, modulation part, the different topologies, and these two parts I have already covered. Next, from the next class onwards I will be covering the modulation and line coding part, and before that I will be trying to cover up the digital and analog signal, along with that what is the different types of digital and analog signaling that is available. Okay, so I am coming to the last end, that is a physical layer is the bottommost layer that we have, and that is in terms of individual the form of the data is in form of the bits, that is hopping from one node to another node. So this is the basically TCP/IP model you have seen. So what is the fundamental difference between TCP/IP, can any of you tell? That is your assignment kind of, you can write down the question, that what is the difference between TCP/IP and OSI model. You write down the question. So 2 questions I have given in the previous slide, that I hope you have jotted down, and this question will be the difference between the TCP/IP and the OSI model. the fundamental difference is that OSI model, in case of OSI model, the 5, 6, 7 layers are combined into the application layer in the TCP IP, and the OSI model 1, 2 may be combined into the network access layer. Okay. So, this is like that, like the data link and the physical layer can be combined, and the upper 3 layer can be combined into application. So, in case of OSI you have application presentation session, but in case of TCP IP you will be only having the applications. Okay. So, you can go through the normal book and you can find it out what is the fundamental difference between TCP IP and OSI, and otherwise next day we can discuss. Okay. So, it got stuck. Okay, thank you all for here in this yes, vertical approach, that is correct. Yes, vertical and horizontal approach, that is the correct one. I need few more differences, so I hope you will learn this one and you can give me the proper solution for this. Okay, so thank you all for your patient hearing. I am ending the stream here.